everyone. In the next 5 minutes, we're going to explain our proposal. We are from Jinxing High School, and I'm Alice. I'm Jennifer.
I'm William.
These are our outlines. Okay, our topic is weights on an elastic band. This is a topic from the International Young Physicists Tournament in 2022. In the original experiments, they're exploring the two metal balls connected to a twisted elastic band and release it and observe its motions. Okay, and we're going to redo this experiment and explore the motion of two metal waves connected by a twisted elastic band in a microgravity and low friction environment. Because of some technical difficulties and due to the friction, we can't use weights on Earth because the friction affects the movement of the two masses. But we can do this in space because we don't have to worry about friction. We are to compare and observe the differences in the motion of the balls in a microgravity environment versus on Earth. In the experiment, we expect that the motion of the device might be very complicated, but theoretically we know that the motion of the device will adhere to the conservation law of energy and the conservation law of angular momentum. In this formula, we can know that as the elastic band untightened, the elastic potential energy will convert into the kinetic energy. And as the energy alternates between the potential energy and the kinetic energy, the device will exhibit an oscillatory motion. Next, as we look at the second formula, the device will adhere to the conservation law of angular momentum. This will drive the two masses to exhibit an anti-symmetry motion. And we will show you what it will be like later. Oh yeah. Let's pretend that my two hands are the two masses. And pretend my arms as the elastic band. It would turn like this or turn like this. We don't know exactly how it would be like, but it won't turn like this because the principle doesn't allow it to become like this due to the conservation law of angular momentum.
Next, I'll explain the tools needed and the experimental steps. The experiment requires two pieces of weight and a piece of crude rubber. After preparing, first cut the rubber band into half and tie the weight to both ends of the rubber band. Then, twist the rubber band and release it. After releasing, observe its motion. The total time for this experiment is approximately 3 minutes, which is under the time limit, and the exact time is mentioned in gray after it. And there is a diagram which we have to highlight.
So this is a prediction that we do in decimal speed, and the blue bar represents the metal weight, and the orange is the rubber band, and the gray is one of the predicting that we do. And on the left side, you can see when we're on Earth, because we need to do this experiment on the table, so it can only be 2D. But when we're in the space, there is no gravity, or nearly no gravity, so it can float in space. So we can not only observe the straightness of the rubber band, the rotation of the metal weight, but also the acceleration along the d-axis.
We're going to show you the prediction that we drew in
This is the animation that we do in the decimal 3D.
It's going to be likely to be one of these, I suppose.
We don't know which one is true in the practice, but that's why we need to experiment with. Thank you, everyone.